Yo, what's up, guys? Thank you guys for joining the stream. Looks like we're back. Damn, it's unfortunate that we had to stop the other stream, but I'm a man of my word, and I said I was going to do these live coding sessions with you guys, and I didn't want to let anybody down. I know you guys depend on us to start guiding you guys through the process of learning how to code, just the basics at this point. We're still in the beginning of this, by the way. We're still in the very beginning, infancy, baby steps here for you guys. But even though the other stream was trending upwards, and after yesterday's stream that was a little bit lackluster, damn, it's kind of unfortunate that we had to end it early. But it doesn't matter, man. Grind don't stop till the casket drop. You guys know what how the saying goes. You motherfucker jump scared me the shit out of me. So here we go. Here we go again, guys. I'm just waiting for the Xcode to load. I got the book open already. If you guys downloaded the book already, if you go to the Discord, you go to the Learning to Code panel. We switched books last week because that book that we posted the week before is a little bit outdated. So we jumped to this new book, Develop in Swift Fundamentals for 2024. We're in section 1.3, constants, variables, and data types. I will go ahead and paste the stream in the Discord as well, in case anybody is in our Discord but misses the stream, or they want to go back and watch anything. What's today? Today is February the 9th. February the 9th. Stream. There we go. So that they can go back and watch the stream if they want to reference anything. This is going to be a pretty simple, straightforward stream, to be honest. Constants, variables, and data types is pretty simple to explain. I don't see any real complicated, difficult concepts. Why is Xcode taking so long to load? Where's my loadout? Taking forever. I want to open up Xcode first. I don't want to jump into it in the book without opening Xcode. Come on. The problem is that Xcode takes so much freaking computer resources too. Come on, open up, baby. Well, while we're waiting for that to open, I'll go ahead and start reading through this. Let's go ahead and change this so you can see the screen. Is that still readable for you guys? This scene? So we can see that the chat's not covering the actual book. Damn, I don't know why this is not loading fast enough. Anyways, let's just start the reading. So, lesson 1.3, constants, variables, and data types. Building apps and programming in general is all about working with data. As a developer, you'll need to understand how to handle and store data using clearly defined types. In this lesson, you'll learn how constants and variables enable you to name pieces of data so they can be used later in your program. You'll learn to define constants for values that don't change and to define variables for values that do change. You'll also learn about types, which are like blueprints for working with data. Different types can be used and stored in constants or variables. You'll learn what types are included in Swift and how Swift types can help you write better code. What you'll learn. How to represent numbers, strings, and booleans using native Swift data types. When to use constants and when to use variables. How to assign values to constants and variables. How type inference helps you write clean code. How type safety helps you write safe code. The vocabulary here, pretty simple. Bool, which is true or false. Constant, which means a variable that doesn't change. Comment, just comments that developers use to reference changes in code or just code in general to other developers or themselves. Double, it's a type of number. Function, which is a method, which is like an executable snippet of code. Immutable, which is basically the same thing as constant. It just means it can't be changed after it's set. Int, which stands for integer, which is a number. A full number, like 1 through 10, 1 through 100, no decimal points. Let, which is the key word to define a variable when it's a constant. Mutable, which means that an item that can be changed after it's set. property, another name for variable, basically. Type inference. Type inference just means that the compiler that's creating the program is able to determine what the type is without you explicitly telling it what type it is. Type safety. Type safety just means that when you define a variable as a certain type, you cannot change it after the fact. So if you create a variable that's an integer, it will always be an integer. You can't mix and match. There's other languages like JavaScript, for example, where you can mix and match. And I think that for me, my preference is type-safe languages, because type-safe languages, when there's a bug or a crash, it's very easy to find the issue. If it was a language where there was no type safety like JavaScript, you might have a situation where you have a variable that was defined as an integer. Let's say the integer's name was 3. Here, I think it is opened. So you created a variable called number of chairs, right? And you defined this variable as 3. Right? So right here, by you setting it as a number, an integer 3, the compiler now infers that this will always be an integer, right? Let's drop a comment. Integer, right? So now I can't go in here and set number of chairs to string 3, right? If I do this, let's comment this stuff out above here anyway. Sorry. Let me just comment everything out so we don't have all this old stuff. What am I doing? Okay. So if I do this, you'll get a compiler error. It says cannot assign value of type string to type integer, right? What this is basically telling you is that the value of this variable is supposed to be an integer, but we assigned it as a string. There are languages, law says, so whatever your variable is cannot be the same as an integer. No, so if your variable is set as a, so if your variable is set as an integer, this is an integer, right? You can't switch it later on to a string. And vice versa. If I made this a string, if I made this 3 as a string, and then I made it down here, I tried to change it to 3 as an integer, I'll get the same error. Except it will be reversed. Cannot assign type integer, int, to type string, because it's already set. The same thing as if I do an optional. So I could also explicitly define number of chairs as an integer. And if I make this a string now, I'll still get the same error. Variables are just boxes. That's how I've always thought about it. A variable is just a box, a container that's holding a value. And then you're telling the compiler what type of value the box is holding. So when you explicitly name the type, like how I'm doing here, where I said int, it's kind of like you have a marker, you have a Sharpie, and you're writing on the outside of the box, integer, string. Whereas if you're just doing it explicitly, like this, you're assigning a variable implicitly, where you're not telling the compiler what you have in it. The compiler is just assuming what you have in it. It's kind of like you just have a transparent box and the compiler is looking inside of it without you telling it. So now if we print this out, number of chairs, it should print out the number 3. Assuming my computer doesn't crash. I need to get a better computer. This computer is kicking rocks. Yeah, so Alex, a variable is just a container. A container that stores value. Whatever value you're putting in it. You can basically assign any value you want to the variable. This is taking forever to load, though. Yes, and also right here, this keyword var means that it can be changed in the future. But if I change this to a let, right? If I change this to let means it's going to be a constant. So the value of the variable can no longer be changed. So now you have an error here saying cannot assign to value number of chars is a let constant, which just means that you can't change this value anymore. So based on what you need the variable usage, you will determine if it's going to be a constant or if it's going to be a variable. Like if you're writing a program and you know you're never going to need to change this value ever, for example, my name. My name will always be Scott Leonard, right? It's not going to change. So when I'm writing a program, if I'm writing a program that has names in it and it's going to have my name listed, I know my name will never change. So I'm going to make my name a constant from the very beginning. Whereas my age can change. So we'll make another variable, years equals, let's say 10 years, right? And now we're going to go, see if I can even remember how to do this. Years. I can get this to do this thing here. Damn, I don't remember how to actually do this. The bottom line is that the years are going to change. I'm trying to do some stupid shit. And I'm like, can't remember what I'm trying to do. Anyways, okay. So, okay. So we went through this type inference, type safety, variable, and var. Var is just a keyword for when you're declaring a variable, and variable is obviously the container. Go to the next page here. Constants and variables associate a name like age or name with a value of a particular type, like the number 29 of a string or the string Andre. You can then use the name to refer to that value many times in your program. So what they're trying to say is that when you give the variable a name, for example, this one's called my name or my age or years, now this becomes the reference point for this container. And you can use it anywhere in your program. So in your entire program you're writing, you can just reference back to this name signature that you've created when you set the variable to start with. You can then use the name to refer to that value many times in your program. Once it's set, the value of a constant is immutable, which means that it cannot be changed. In contrast, the value of a variable is mutable, which means that it can be changed at any time. By defining a constant or variable, you're asking the compiler to allocate storage for the value in memory on the device that will run the program. You're also asking it to associate the constant or variable name with the assigned value so you can assign the value later. Constants. When you want to name a value that won't change during the lifetime of a program, you'll use a constant. You define constants in Swift using the let keyword. So that's why when we defined it here, this my name, we used the let because it's not going to be changed. But when we did the age and the years, we defined it as var, right? What are you guys asking? Why would I use a var instead of a constant? Oh, Alex, because you might have, for example, let's say you have a car, right? You're making a program that calculates how many miles a car has on the odometer. That number is going to be changing, right? It's not going to stay constant. So it might start out at 0, but if the car drives 50 miles, then each mile is going to add a number to that counter, right? And that's the variable that's holding the total of the miles the car has driven needs to be incremented. That's why. Whereas the brand of the car or the serial number for the car, the VIN number doesn't change. So those are going to be constants. It's just when you're writing the program, you're going to have an idea of what you're trying to accomplish, right? So if I'm making a car, if I'm programming for like the embedded chip, what is it called? The thing you plug into the car, what is it called? You know what I'm talking about. The thing that you, when you're gonna like tune a car, the damn it, I can't remember what this fucking thing is called. The ECU. So you're programming the ECU of a car, right? The ECU is gonna have many different values. It's gonna have variables and it's gonna have constants. And for example, the constants might be like the brand of the car, the model of the car is the VIN number, the engine serial number, the torque value limit, the torque value limit, the oil pressure heat sensor limit where it tells it like when it's overheating or underheating. Those will always be constants, like because we already know what the parameters are. The tension that is required before the belts are need changes, those are gonna all be constants because they're not changing. But then things like the fuel level, that's gonna be a variable. Things like the oil level will be a variable. Engine temp will be a variable. Mileage will be a variable. All of that kind of stuff that's gonna be constantly changing. It's not gonna be static. Those will all be variables. But it's like when you're writing the code, you're going to know what you want to do. So you'll know what needs to be a variable and what needs to be a constant. Some people get lazy and they make everything a variable, but it's just that's just sloppy coding. So let's see. Constants. When you want to name a value that won't change during the lifetime of the program, you'll use a constant. You define constants in Swift using the let keyword. Let name Andre. The code above creates the new constant called name and assigns the value Andre to the constant. If you want to access that value in later lines of code, you can use the name to reference the constant directly. This quick reference is especially helpful when you have one value that you use many times in your program. So then they just showed an example where they have the name of the variable and then they reference the name of the variable in this print function, which prints out the name Andre, which is what's in the container. Because name is a constant, you can't give it a new value after assigning it. For example, the following code won't run. Yeah, let name equals Andre, name equals Elena. You'll get an error. So look, I'll paste this in the chat, not in the chat. I'll paste it in Xcode so you guys can see what happens. I can't paste it. We'll just use it over here. So my name equals Tommy. When we try to do this, we'll get an error. Cannot assign a value. My name is a let constant, right? But if I make this a var, now you'll see. Now you see the error will go away. Okay. Does that make sense? Okay, so then variable. And also, I don't know why they called this constants and variables. Honestly, in the industry, when we're working, we call all of them variables. The constants we also call variables. Like, we kind of know just by looking at the keyword if it's a constant or not. So I feel like that is a little bit misleading because most people are just gonna call everything a variable. But anyways, variables. When you want to name a value that may change during the lifetime of an app, you'll use a variable. You define a variable by the var keyword, var age equals 29. This function prints out the word age, and prints out the value of age. The code above would print out 29 to the console. Because age is a variable, you can assign a new value in later lines of code. The following code complies with no errors. So we started out with the age being 29. They referenced the name of the variable age here, and they set a new value of 30, and they print out age, and it prints out 30. The code would print out 30 to the console. You can assign constants and variables from other constants and variables. This functionality is useful when you want to copy a value to one or more other variables. So in this example, you can see they have a constant called let default score equals 100. Then they created two variables, player 1 score, player 2 score. These are variables, they're mutable. and they set the value that was inside a default score to the value of these two values. So now when you print player 1 and player 2, you're going to get 100, 100, right? Then they went into player 1 score and they changed player 1 score from 100 to 200. They printed it out and now the value is 200. Santos says, remember I told you your chats are full of incels and gooners. Only 2 people watching this. Don't trick. Does the age variable have a cutoff number, or will it leave it open to any age, even 200? Oh yeah. Don't trick. There's no limit. There's no limit. And there is a limit, but the limit is extremely, extremely large. Like if we Google that really quick, we can find it. Give me a second. It's gonna be like a crazy number. Here. So the integer limit, the highest number you can use for an integer is gonna be this number. You guys see it? I don't know what this would be. What is this? 2 billion, right? 2,147,483,647. So you should be good. You should be good. There's a high chance that you're not gonna get to this number ever. Shouldn't there be an option for a limit when certain things have limits on age? Oh, you don't trick. Yes, you can do that, but it's not like a set limit. You'd have to set the limit yourself. So, you'd have to write the code so it doesn't allow for you to get to past that number. But itself, as far as like a plain variable, it's not going to have an actual limit. So if you wanted to do something like that, I guess we'd do something like while, here it is. I gotta set a new value now. My age equals 29. So it would be something like while my age is less than 150, my age equals there. I think that's what I'm getting confused with C here. So now with this kind of logic, now you're restricting the limit. You're putting a limit on this, right? So my age will never be past 150, but you have to do it yourself. The programmer is the one who's in full control. Like the computer is not going to stop you from doing whatever number you want. You'd have to write your own code so that it doesn't pass the limit. So here I'm setting a limit of 150. Constants and variables. You just learned to use a constant when the value won't change and a variable when the value might change. But there's a nuance. Here that's worth learning. Even though certain values might be variables, you can represent them with a constant because they won't change during the lifetime of a single execution of the code. Imagine you're calculating information about the distance traveled on a trip. The program can be reused to track many trips over time, but it tracks one trip at a time. How would you represent the following data in the computer? Starting location. This is the starting location. This is a GPS coordinate of where you start your trip. Once you begin tracking a trip in your program, the location won't change. You'll represent that value with a constant. Destination. This GPS coordinate is where you want to arrive. Your app can be used for many destinations, so you may think this would be represented with a variable, but once your program begins tracking a trip, the destination won't change. You'll represent this value with a constant. Current location. The GPS coordinate of your current location will change whenever you move. So you'll represent this value with a variable. Distance traveled. How far have you traveled from your starting point? This value changes as you move. You'll represent it with another variable. Remaining distance. How far must you travel? How far must you travel to arrive at your destination? The remaining distance changes as you move. You'll represent this value with a variable. Constants and variables perform very similar jobs. You may think it would be easier to use variables for everything and ignore constants altogether. Technically, your code could work this way, so why should you use constants at all? First, if you set a value to a constant, the compiler understands that it should never be changed. This means you won't be able to build or run your program if you try to change the constant value. In this way, the compiler enforces safety. Second, there are special optimizations that the compiler can make for constant values. When you use constants or values that won't change, the compiler can make low-level assumptions about how to store the value. The adjustments allow your program to execute faster. So basically, they're just saying that it's going to be optimized. This is the reason why you should use variables and constants and not just make everything a variable. Because the thing is that if you make a constant, the computer is going to create that constant in a lower level in the memory because it won't have to access it constantly to change it. But if you make everything a variable, then everything's going to be in the top layer and it's just going to cause fragmentation. It's going to make your program way, way slower. Third, it's an idiomatic or accepted way to do things in Swift. As you learn more about building software, you'll come to appreciate best practices for consistently writing clean, readable code. This is especially important when working on a team with other developers. You'll also discover that following best practices will make it easier for you to remember what your code does, especially when you want to make changes later on. If you want to be a great developer, you'll need to follow shared patterns and conventions. This course will guide you towards the best practices for Swift writing. Naming constants and variables. Yeah. So even when we name the variables and the constants, we do it a specific way when you work with a team because people will lose their shit if you do it a random way, the way you want it. If you do it randomly, you're working in a group with other people, they'll get so mad. It will be a whole huge issue. Naming constants and variables. There are rules for naming constants or variables. The compiler enforces the rule, so you won't be able to build or run your program if you break them. Names cannot contain mathematical symbols. Names cannot contain spaces. Names cannot begin with a number. Other than these three rules, you can name constants or variables whatever you like. So you see how they did like pi, they used the pi symbol. Let, I don't know what this means, Japanese symbol for 100. Let dice, they used emoji for the dice. Mañana, Spanish, tomorrow, and then German for number. In addition to these rules, there are some best practices for naming constants and variables. Don't Trick says, what makes Swift a code iOS? What it's used on? Yeah, it's mainly just because it's the programming language that the iPhone is able to interpret. Because remember that when you create the actual device, the device has a chip, right? And the chip has a ARM. The chip has like a predetermined languages that it can understand. So everything for iOS is basically Swift or Objective C, because those are the only two languages that your device is going to be able to run. Oh, an iPad and the Mac, obviously. Even though I don't really use, I don't actually code. I've never coded anything for the Mac. I mean, I could if I really wanted to, but I have never actually done it. If I'm keeping it a buck with you guys, I haven't coded anything in a while. Any like real substantial code. Because the problem is when you work at one of these companies, if you become like a manager and you're managing other people, then for the most part, you're really not doing that much. Like I just come in, I tell other people what we need to do. I pick up one or two tickets that are usually pretty simple. I'm not writing code constantly. So this is a refresher for me as well. It's a refresher for me as well. Oh, and Apple is the company that mainly developed Swift. In addition to the rules, there are some best practices for naming constants and variables. Constants and variable names should be clear and descriptive. Making it easy to understand the code when you come back to it later. For example, first name is better than N. And restaurants near current city is better than nearby. Exactly. So when you name the variables, for example, let me open up a project I have. One of my old projects. So you guys can see firsthand what I mean. Maybe this one. Let's see how long it takes to open. Hopefully it opens quickly. And I can show you guys what I mean by the naming conventions. This is old. This is like 4 years old. It's like 4 freaking years old. Let's go to something simple here. Computer is really sucking. I wrote tests. This doesn't really have that much stuff in it here. These are just functions. This is all right, but I want to find the good one. I guess where we were at is the best one. So this models are kind of like classes that you make yourself or types that you make yourself. So this application was for portfolio app messages. I had an app that people could go to a website, and on the website they could fill out like a form, and the form would generate a message and it would send it to this app, and then I'd be able to read the app on the iPhone, right? So I made a type called message, right? Message. And you'll see that the variable names, they're straightforward: name, phone, email, message, ID. And then I actually made the types explicit. They're all strings, to be honest. But there's just telling you that when you're naming the variables, you should give them clear names of what they are, like name, phone, email. I didn't call this N. I didn't call this P. I didn't call this E, M, or I. Because then when you go back, you won't know what the hell you did. This is not like a great example. Let me see if I can find the better app that had more shit in it. Because this was like a really simple app just to read messages. See if you can find a better example that has like more stuff in it. Okay, we'll just open it manually here. So a while back, I made a clone, an Instagram clone. Let's see. Where is it? Don't tell me I erased it. Projects. Okay, Petstagram. So I made an Instagram clone like a long ass time ago. Let me show you guys the artwork too. I made all of this stuff myself, by the way, the artwork and everything. Might as well show it off while I'm in here. Here. Projects. Instagram. So all of this stuff, I made this myself, including the artwork. But essentially what this was it was an application that was a clone of Instagram. Because remember that when you're going to go find a job, you need to have like examples of work that you've done in the past. They want to see examples of the code. They want to see examples of what you did. And they want you to show you like a proof of concept. So one day I just sat down, I looked at Instagram, and I was like, okay, I'm just gonna reclone Instagram. I'm gonna do everything that Instagram has. I'm gonna do it myself from scratch, right? So I sat down and I wrote my own application that basically was just Instagram for pets. It had all the features Instagram had at the time, but for pets. And then I made the artwork and everything. All of this stuff, the artwork, the logo, all of this shit, I made it myself. Photoshop, Illustrator. Because I'm out of my goddamn mind. But that's how you get a job. Don't think that just learning how to code is what's going to get you the job. What's going to get you the job is doing like all the projects on your own, and then being able to show them the projects and explain what you did. That's what gets you the job. Lal says I started coding games in high school in Java. It's so ass, bro. I don't like Java. Seems more forgiving. Yeah, Swift is way, way better, in my opinion. It's easier. So then if I go into, let's see, Instagram, if we go into the models, you'll see that the names of the items, so email, password, username, pretty straightforward. Here, the class I created, user profile, you automatically know what it is, user profile. And then image data, the image that was going to be attached to it, the user, this is the user's user ID, database, storage, image caption, right? Everything has a clear, easy to read name. Here's a static private var. This is the var variable that's accessed from the class level. Shared user profile. It explains exactly what it is. All of the names are self-defining. You know, you don't need to go look up a dictionary or look up in an index to find out what each thing is. It tells you. Even the functions. Look at the names of the functions. This function's name is upload data to Firebase, which basically tells you what it does. It uploads data to Firebase. You don't have to go look it up somewhere else to find out what it does. Everything needs to be descriptive in a way that a person can just glance at it and know. And then I also added comments to this. Normally, to be honest, when you work in a big company, we don't add comments that often. But since this was like an example project to show to a recruiter and a hiring manager, I did add comments everywhere. So you can see like here it says creates an empty data object that sets an image data. Then here it tells you what you're doing, uploads data storage and image data to Firebase storage inside folder under the user ID. Like I explained everything in the comments. Same thing here. Contains object that will be used to data store, snapshot of the user profile, view controller. And then this is obviously the account images. This is just the class that holds the images that the account has. It has the account, the username, the name of the image, the actual image, the timestamp the image was taken, the metadata for the image, and the image ID. Yeah, this is, and by the way, Lau, this is when I was just learning too, bro. Like, so I feel like even this is kind of sloppy. Like when I started working at a real company and I went back and looked at this, I realized that it was still kind of sloppy. But it's pretty, I mean, for a beginner, this was when I first started learning how to code. I think it is pretty clean, but it's not as clean as like when you work in a real company. You start seeing how they really, really do it. Because the way they do it at the company is so much more organized. But you see how I separated all the models, right? With all the different model classes. And then we have the views, which are the places where the actual models are consumed, which are all simple. These are all pretty simple. Oh, and here I use the storyboards, I guess. That's why I'm using like the IB outlets. I hate, now that I work in a big company, we never do this. You see how these have like these little boxes next to them? It's because what happened is I used a storyboard. So if we go over here, you'll see like these things here. Look. If this loads. Let's see if it loads. Yeah, well, this isn't my work. This is don't trick. This is like side projects I did when I was first learning how to code. Damn, it's taking forever to load. The thing with Swift is such a beginner language that you don't even need to know how to code to create something. In the sense that, look, here, the user interface is not coded. What I did was I used the UI, and I built the UI in this UI builder, and then I attached a little bit of code I wrote to the UI builder, and it was functional. This is taking forever to load. But now, while I work in a real company, see how I just made the UI? See, we made the UI here in the UI builder, and then we attached the code. I attached the code to this UI builder. But now that I work in a big company, we never do this. We make everything from scratch. There's no UI being built in a fucking UI builder. Because this UI builder is extremely hard to maintain once you once you work with like, if you're working with like 1,000 people on a project that has thousands and thousands of files, this UI builder becomes a mess. So we never use these anymore. At work, I've never used a UI builder for anything. But as you can see, when you're a beginner coder, it does come in handy because look how this has almost no code in it. See, these classes have almost no code in it. It just has UI table view cell. It has the delegate. It has the account, which is the type. And then I had like the UI builder, and I just attached everything. IB outlet, IB outlet, IB outlet. And I just had the little bit of functions I needed, and it ran like that. But now, if I was working at the company I work at right now, this would be like a giant file. It would have a bunch of stuff because all of that UI would be built in code as well. Whereas I didn't do anything built in code. Here I didn't any either. You can see this is a feed table view cell. It just has the outlets. And I just attached it to one of these UIs that I built in the UI builder. Let's go to one of these controllers and see what I did over here. Yeah, there is some logic here, but it's not like super meaty. But my point of bringing you guys here was to just show you that every single variable, like this encode password, which is a constant, by the way. You can see this is a constant. These were all constants too. The account is a constant. The password is a constant. But the status, you see how the status isn't a constant? The status is a variable because the status changes. The status has 3 types. It could be a success. It could be an item not found. It could be a failure. So when we created status, status was a variable. Whereas when we created encoded password is a constant because the encoded password is never going to change. And then look at the function names. Save password to keychain. Retrieve password from keychain. All of these are names that are not changing. Names that, tell you exactly what they do. Does that make sense? Sorry, guys. Somebody was calling me. Does that make sense, though? That the functions tell you exactly what they do. Retrieve password from keychain. Save password to keychain. This variable query. This constant access group. Constant service. The struct generic password. Everything has to be clear. Because remember that when you go back, like this, I wrote this 4 years ago. If I didn't have everything clear, like let's say if you wrote this sloppily and it just had random names like keychain, Q, S. If I go back 4 years later, I wouldn't know what any of this means. Oh yeah, Lal says, I'm following you. My only confusion is strings. Do the strings just connect to variables and constants? Yeah, strings can either be variables or constants. I don't have any strings here. Let me see if I can find an example of a string for you. Where could I have a string? Maybe in the app login. Oh, okay. And also this app login, this one I didn't write with the this one I didn't do with the storyboard. You see how this one actually has the items built out? It has everything built out. These are all strings, by the way. Wow. When you see, at least on my computer, I have them set so they're like the red text with the quotation marks. These were all strings. I don't have any hard-coded strings in here, though. Oh, here, okay, so this is a string getting passed into a function. So it's like a web connecting the two separately, and the string needs a variable or a constant, not both, like you said earlier. A variable cannot be a constant. Yeah, technically, in my opinion, and how we always refer to it at work, like this, okay, error alert, right? Error alert is a constant. But nobody really, no, in the real world, nobody really ever says like, oh, this is a constant. Let me go change. Let's set these constants because it just seems redundant. We just know that it's a variable that cannot be muted. It's immutable. So what it means is that the variable can never be changed because constants are variables. They are variables. All variables are const. No, all constants are variables, but not all variables are constants. Does that make sense? Let me write that in the chat before I get. I don't want to confuse. Let me write it in the chat. All constants are variables, but not all variables are constants. There. Does that make sense? It's like saying all buses are automobiles. No, that's a bad example. All trucks are cars, but not all cars are trucks. Does that make sense? I'm just really bad at explaining, I guess. No, strings are just text. So like what they mean by strings is it's just plain text. When this application builds, the user will see log and error. But I think they're going to get into it in this next section here. Comments. Okay, so comments. You guys already comments. I don't know if I need to read all of this about the comments. Basically, comments are just what the developers see when they're looking at the code. And to define a comment, you just put these two little lines, these slashes, and everything after that slash will be a comment. And you can see I have many of those here. Like this is a comment. This is a comment. This is a comment. Those slashes basically tell the computer to skip over it, to ignore it. Okay. Okay, so now here it's going to explain the types. This might clear up the string part to you, though. Types. Each constant or variable in Swift has a type that describes its kind of value. In the example you've seen, 29 is an integer that's represented by a Swift type int. Likewise, Andre is a character string represented by the Swift type string. Swift includes many predefined types you can use to more easily write clean code. Whether your program needs to include numbers, strings, or Boolean, true or false, values, you can use types to represent a specific kind of information. Here are a few of the most common types in Swift. Integer, int, represents whole numbers or integers. For example, 4. Double represents numbers requiring a decimal point or real numbers. So 13.45 is a double, but also 4 is a double. So all integers are doubles, not all all integers are doubles, not all doubles are integers. Kind of the same thing. Boolean is a true or false, which is just represented by the value true or false. And then string is just text. So once upon a time, right? Swift also supports collection types, which group multiple values into a single constant or variable. One collection type is named an array, which stores an ordered list of values. Another collection type is named a dictionary, which has a key that helps you look up specific values. You'll learn more about collections in a future lesson. Swift standard library includes all types above, so you can always use them. Yes. And also to use these types when you're writing code at the very top of your file, we'll get into, obviously this is way advanced, but when you start a file, you'll define what you need to use. So up here, we have like import UI kit, we're importing combine, we're importing the libraries we're going to use in the code underneath it. And UI kit would include all of the stuff you need, like all of the base variable types. Okay. In addition, you can define your own types in Swift by creating type definitions. Consider a simple person a type. Struct person. So this is what we were doing here. These models. These models are custom types: authentication, user profile, account images. These are all custom types, which are also called classes or structs. So here they're giving an example. In addition, you can define your own types in Swift by creating type definition. Consider a simple person a type. Struct person, this is the type here, person. And then it has first name string, last name string. Then they have a function, say hello, which is just going to print out the first and the last name. You can think about type definition as a blueprint. A blueprint designates how to construct a building, but isn't a building itself. However, you can create many buildings from a single blueprint. A type definition declares the information it stores, properties, and its capabilities or actions, methods. In this case, a person stores string information in two properties, first name and last name, and has one action, the method say hello. You're probably unfamiliar with all the syntax above, but that's okay. For example, above describes how the type person should look and perform. When you create a type and assign it to a variable or constant, you're creating a version of the instance of that type. Thus, an instance is a value. Consider the following code. Let a person, then he calls person the type, first name Andre, last name Lorenko, and let another person, this is another variable, right? Person, and he defines the types again here. And then he says a person dot say hello, calls the function, and both of these are going to print out to the console, hey, hello there, my name is Andre Lorenko. Hello there, my name is Alina. I don't know why they always choose these stupid names. Their examples always have like the weirdest fucking examples, but let's just pretend this is a name and he just calls out the names that they defined. This code creates two instances of person type. One instance represents a person named Andre Lorenko. The other instance represents a person named Elena Ziangin. I cannot pronounce his name. You'll learn more about defining types in the future lessons. Type safety. Swift is considered a type-safe language, so this is why I like Swift the most. Range. So strings are ones and zeros to binary. I got it. Yeah, I get it. Okay. Yes. So this is why I like Swift, because I tried, I wrote a few websites in JavaScript. JavaScript is not type safe. What that means in JavaScript, I can make a variable called player name, and I can call it Julia. And then I can go back and I can change player name to 1000 and I'll get no error. And what happens is when there's no type safety and you build an application, it breaks. It's very hard to find what broke it. You have to go through all the code essentially. I hate that. So the reason Swift is such a superior language is because you're on rail tracks. You're on tracks. There's no way for you to make a mistake like that. There's no way to make a mistake like that in Swift. On JavaScript, when you're making a website, the website might say, for example, let's say the website has a field, a search field, and it has a maximum character length of 120 to 28 characters. You might put maximum character length 128. But then down in the code somewhere else, you might put maximum character length and you might type it out by accident, right? And now there's a mistake in the code and it will take you forever to find it. You'll have to search and search and search. You'll have to go through the code multiple times. It's just very, very annoying. Swift is considered a type-safe language. Type-safe languages encourage or require you to be clear about the type of value your code can work with. For example, if part of your code expects an int, you cannot pass a double or a string. When compiling your code, Swift performs type checking on all your constants and variables and flags any mismatch types as errors. If you mismatch types, you cannot run your program. Let player name equals Julian, var player score equals 1000, var game over equals false. Player score equals player name will be flagged for mismatch types, will not compile. Lau says, I used to stack my code in Java to prevent that, or I'd work on 4 projects at once, then combine them. Yeah, it's too, I don't like it, dude. I really don't like it. That's why I picked to become an iOS developer from the beginning, because being an iOS developer is easy. It's easy. It's easy because, first of all, you're working in an IDE that you can see with your own two eyes. You can build the application on a physical device and look at it, and you can see the errors for your own self, and it's type safe. Whereas building a website or building other freaking, being like a embedded software engineer where you're not looking at the code, the actual physical product yourself, it's very hard to find any errors. Swift is pretty much, it's a fun language. Because type safety enforces the type of a constant or variable can hold, assigning a string to a variable that only holds an int doesn't make sense. You'll learn how Swift figures out the types shortly. Type safety also applies to variables, constants, and literal values that represent data that may seem compatible. For example, Swift recognizes int and double as completely different types, even though they both represent numbers. Var whole numbers equals 30. Var numbers with decimal equals 17.5. Whole numbers equals numbers with decimals will be flagged for mismatched types, will not compile. In the case above, both variables are numeric types, but whole number will be an int, and number with decimal will be a double. In Swift, you can't assign a value of one type to another variable of another type. When working with numbers, you may find that you need to assign a very large number to a variable or constant. This can be difficult to read since it is hard to see how many zeros there is in, I don't know what number that is. Fortunately, Swift allows you to put underscores in your numbers as a way to format for easier reading. So large ugly number, it's all together. Large pretty number. Now you can see that this is actually 1 billion, right? 100, 1,000, million, billion. Yes, 1 billion. Type inference. You may have noticed that you don't have to specify the type of value when you declare a constant or variable. This is called type inference. Swift uses type inference to make assumptions about the type based on the value assigned to the constant or variable. Let city name equals San Francisco. San Francisco is obviously a string, so the compiler automatically assigns that type of city name to a string. Let pi equals 3.1415 is a number with decimal points, so the compiler automatically assigns the pi to double. Once you assign a value to a constant or variable, the type is set and cannot be changed. This is true even for variables. The value of a variable may change, but not its type. You might find cases where it's useful or even required to explicitly specify the type of a constant or variable. This is referred to as type annotation. To specify a type, add a colon, a space, and type the name following the constant or variable. So this is what they're doing here. Let city name, and then here they're defining the type, colon, space, string, equals San Francisco. And here they did the same thing. Colon, space, double, equals 3, 14, 15. You can use type annotation with different number types. Swift compiler will adjust the values to match the type. Yeah, it's super good, bro. Swift is like one of the best languages to learn. If you're a new developer, okay, we're almost done. If you're a new developer and you're trying to learn to program, I would always recommend starting with Swift or Kotlin for Android. Modern languages, they have all of the protections. They do basically everything for you. Psalm 4 says, hey, bro, making is easy, even apps. Yeah, Swift is easy, bro. Believe me, it took me 6 months to learn it. And to get a job, it took me like 8 months. I mean, altogether. So altogether, the entire time frame, it took me 8 months total. There are 3 common cases for using type annotation. When you create a constant or variable but haven't yet assigned a value to it. Like here, this is an example where there's no value. This is an empty variable. When you create a constant or variable that could be inferred as more than one type. Let middle initial character equals J. So they're specifying it's a character, not a string. J would be inferred as a string, but we want a character. So they're explicitly telling the compiler we want it to be a character, not a string. Same thing here. Remaining distance double equals 30. 30 would be inferred as an int, but the variable should support decimal numbers for accuracy as the number decreases. When you write your own type definition, they created a struct here and they just defined each type string, color, string, year, int. Required values. Whenever you define a constant or variable, you must either specify a type using a type annotation or assign it a value that the compiler can use to infer the type. Var x, this would result in an error. Yep. Even when you use type annotation, your code cannot work with constants or variables, with a constant or variable if you haven't yet assigned a value to it. So here, var x dot is an int, print x, there's nothing in it, so it's gonna give an error. Once the value is assigned, the constant or variable becomes available. So now here they var x int x equals 10. When they print x, it's going to print 10 to the console. Okay. So we got through it, guys. We got through this whole thing. There's a lab. If you guys downloaded the book, the next section we're going to cover next week. Lesson 1.4 is operators, which is just addition, subtraction, multiplication, and division. If you guys are curious what book we're using for this course, if you go to the Discord, let me paste the Discord link in the chat. If you go to the Discord, the book is actually in the Discord. It's this book right here. Develop in Swift Fundamentals. And then every week we're gonna post the stream link in here as well. So anybody who missed the stream can just come back and reference it. But I would recommend you guys also in your free time download the book. Do the challenges the book has at the end of every chapter. For example, in this chapter at the end it had like some quizzes, right? I'd recommend doing these questions, doing the lab, just so that you can really cement the idea and you can really get a good understanding of it. And then also, if you guys want to learn super quick, Zoom4Check says, Scott Leonard, where you go to learn Swift or what course or school? I taught myself. The book that we're using, I didn't use this book. I used the book that was at the top, this one, this first book. But I think that this book is no longer available. They're basically the same book. This one that's in the first message that we have in the Discord chat. They're essentially the same book, but this one that we attach is the new version of it. But all I did, and I was gonna say we can have like a little Q&A session right now. All I did was I read through that book. I did all of the assignments in the book. And when I finished the book, by the time I got to the end of the book, I knew everything I needed to know to get a job as a developer in a company. At least the basics. So anyways, guys, my throat is really hurting from reading. I didn't realize it was going to hurt that much to read a whole chapter, a whole section in the book. But does anybody have any questions? Let's take a few minutes to have like a Q&A before we end the session. Anybody, feel free to ask me any questions you guys have. And like I was saying earlier in the other stream, the reason I'm doing these is not to make money. It's not anything like that. It's just I want to help the community. I want all my people to be up, because I feel like when the people around you are able to escape any financial situation they have and they're up, then it helps you too, you know? I want all my people up. I want my followers to be successful. And it's all great that we watch like the Fuzi videos and the live streamers and we do reaction content and we have some fun, we laugh, we joke around. But I feel like I'd be doing you guys a disservice if that's all we did and I wasn't helping you guys to get to that next level financially as well. Does that make sense? And it's kind of sad that like don't or was it who was saying that? Maybe it was Santos in the beginning of this stream. It's sad that when we do the educational stuff, yeah, it was Santos. When we do the educational stuff, we get like 5, 6 people in here. But when we do like the clown shit, we get like 100 people, 50 people, 20 people. And it's like, dude, like it's great. Like it's fun to have fun. It's fun to have fun, but I feel like, look, you guys see me every day streaming and you see the level of freedom I have to be able to do that. And wouldn't you want to also have that same level of freedom and autonomy to be able to just chill in your house, work from home, have free time to live stream, and also have like the McLaren, be able to like afford the lifestyle you want, have fun and have freedom? I don't understand why some people they only want to have the fun parts. They don't want to do the work. You got to do if you want to have the successful lifestyle, you got to do the work, you know? And I do a lot of other stuff other than just live streaming too. I'm trying to run this merch brand, which honestly at the moment I've kind of let it go a little bit, to be honest. But I also run this merch brand. I do a lot of other things. And the grind don't stop, man. The grind don't stop. If you want to be successful in this life, you got to put in the time. You got to put in the effort. You got to focus. You can't just be all fun and games 24/7. Out here working retail, dealing with dumbos all day. Yeah, I know, right? Weebo's Chuck E. Cheese heads, right? But those other people, like, they only want to join when it's fun and games, man. And then they want to complain, like, oh, man, my life isn't where it's at. Like, look, 6 years ago, my life wasn't where it was at either, man. It wasn't where it was at. It wasn't where it was at either. I would sit down, I'd play video games, I'd smoke weed occasionally with my brother, and we would just chill. And we had like no money. We were just chilling and we'd complain. But one day I just snapped out of it and I said, you know what, man, I'm tired of this fucking lifestyle. I'm tired of playing GTA, spending all my time in GTA trying to get the money to drive a supercar in GTA instead of driving a supercar in real life. You know what I mean? Like, what would you prefer? Having the supercar in GTA or having the supercar in real life? Having your own apartment in GTA or having your own apartment in real life? Having a girl in GTA or having a girl in real life? Like, obviously, and the crazy thing is sometimes the amount of effort you put in the video game is more than the amount of effort it takes to do it in real life. Think about that. That's crazy, right? Lo says doesn't even sound like a question. There's video games like, okay, when I was broke, I played this game EVE Online, right? EVE Online. And some of the stuff you had to do in EVE Online was harder than the stuff you'd have to do in real life to make the money. It was easier to make $1,000 in real life than get some fucking item in this stupid game. But I don't know why some people fall into that trick where they'll learn a whole system. Because when you really think about it, some of those games are pretty complex. They'll learn a whole system to beat a game, but they won't learn a system to make money in real life. The thing is, you gotta gamify life, man. You gotta gamify life. You gotta see life as a video game. See the skills that you're working on as skills in a game, and you're just acquiring new skills as part of that video game. That's how I see it. But maybe I'm crazy. I don't know. But I'd rather be crazy with the McLaren than crazy with the Honda Civic working at McDonald's putting the fries in the bag. You know what I'm trying to say? What's the dimensions and weight length for making the columns and tables for the App Store? Wait, I don't understand what you mean, Sam. How so? What do you mean by the weight length of the columns and tables? Also, look maxing is important. Got that on lock. What the hell? Nah, dude, I'm working on it still. Bro. I'm scrawny. I used to be anorexic though, bro. Back when I was broke, I was anorexic. Imagine 6'2", weighing 122 pounds. Is that not crazy? 6'2", weighing 122 pounds. I was skin and bones, bro. I was like neon. I'm still scrawny. I'm not even at Sneeko's level yet. I'm still scrawny. I'm still scrawny though. Sneeko's still bigger than me. My goal is to be bigger than Sneeko. My goal is to be bigger than Sneeko. But back in the day, I used to be like neon, bro. Like my arm, you see my wrist? My wrist, the thickness of my wrist, my arm up here was the same thickness as my wrist. It was just the bone size all the way up to the fucking arm. You could see like my clavicles and shit. Like this shit over, I can't see it. This shit over here. This shit was like visible. Like you could see the bones sticking out. You could see my fucking ribs. It was crazy. I don't know what I looked like a fucking meth head back in the day. Low key. Bailey's like, oh, my little meth head. No, but low key, I really did look like a meth head. I'm not even joking. And like, I think I got a photo on my phone I saved. Let me see if I can pull it up. It was crazy, man. So you got to focus on multiple things because that's the other thing. Look, when I was learning all this stuff, I kind of did play a dangerous game of focusing 100% on learning. And that was a dangerous game because sometimes you could learn all that stuff and then you could get sick and die, you know? Because you've put all of your resources, all of your energy into one category. Let me see if I can find this damn photo. I thought I had it saved in my favorites. Oh, yeah, here it is. I'm going to send it to my computer so you guys can see. Right now, I'm working on getting more weight, but also maintaining my maintaining a low fat level. Because the problem I have right now is that after I started gaining more weight, I've gone down the path of gaining too much weight, like in the wrong spots. In the wrong spots. When I first started working out, this is gonna be a little sus, but I'm gonna send it. I'm sending it to the computer too here. Story time over here. Dropping the story time over here. Look. So we'll pull this over here. I'm gonna show you guys something really quick. So you can barely see it because the resolution is so low. But you can see how skinny I was, man. Look at this. Look at my arm. That shit was the same size up here as down here. And you can see my ribs. Look at the rib plate. Look at the fucking clavicles. Look at the shoulders. But one thing, dude, one thing I always pulled. I always pulled, even when I was skinny as fuck. The manipulation level on level 1000. And then this is when I started working out finally. This is a little sus. See, I had a little bit of ab definition. I mean, I still have these 4 top abs, but you can already see it was starting already. Right here, this area on my stomach, I don't know why. It's like I just have bad genes. I have bad genes. And this is when I just started like going to the gym and working out and eating more. But now this fat layer is like even more pronounced. You can still kind of see my top abs, but you can't see the bottom abs. And like I'm trying to figure out how to get rid of this shit. Homie said milk chocolate. I'm cooked, bro. I think I just need to do more cardio, but damn, that shit burns, man. Doing that cardio, that shit's painful. Looking like Will Smith. That shit's painful, bro. But again, maybe I'm just being lazy. Me and Bailey did leg day last week. We should have done a leg day. We should do leg day tonight. We should go to the gym tonight, actually. But we were in pain. We couldn't walk. I was walking like I had got like diddied. Anybody who would have seen me in the apartment walking around would have thought I got diddied because I was walking like a cowboy. Lol, I've gained 50 pounds in 12 months. I'm getting back to it now, lol. I'll send the journal. Maybe I do need to keep a journal. Because I'm fucking it up, bro. But that's the main thing. I just need to lose the belly fat a little bit so I can have the six-pack abs and then just keep gaining more muscle. My diet is fucked up probably. That's why. I went from not eating anything to eating a bunch of junk food. We eat so much fucking junk food. Bailey over here feeding me gummy worms and shit. I think she does that shit on purpose, though. She's sabotaging me. She's like, oh, I gotta make sure that he never gets shredded. Make sure nobody looks at him. Because sometimes I be going out of the house like a complete bum. And I ask her, like, babe, I look okay? And she's like, yeah, you look great. And when I look at myself, I'm like, all fucked up. And I'm like, what the fuck? What does she mean I look great? Sabotaging me. She's like, she's in the background saying, who gives a fuck what other people think? Nah, she be trying to sabotage me, low key. One Piece is selfish Bailey. She thinks that if I get shredded and I'm jacked, that I'm gonna get stolen. I'm not gonna get stolen. So she tries to sabotage me. She's like, oh, you want these cookies? She's in the background yelling, like, oh, you get my fucking fruit snack. You know you can't leave that kind of shit out in front of me. But no, my goal is for the summer to get those abs well defined and shredded. But my point here is that we got to focus on our goals, guys. That's the main reason why I started this live coding session for you guys every Sunday, is because I want to see my people, the people who support me, grow and also be able to support themselves and help other people. I hate these influencers that they get famous, they get big, and they don't want to help anyone else, man. They climb to the top of the hill and they fucking pull the rope up behind them. No one else can come up behind them. I hate that shit. I feel like they don't deserve it. Like, okay, for example, look at Fuzi and look at Ice Poseidon. Ice Poseidon put Deepak on, right? If it wasn't for Ice Poseidon, Deepak would still be a guy in India doing tours. He helped him. He helped him grow. He put him on. He helped him set up his stream. He took this guy out of the poverty, bro. He made this guy a freaking celebrity. Who has Fuzi done that for? That's my point. Bailey's back in the back saying Fuzi's selfish. Yeah, exactly. That's my point. Fuzi wants it to be all about him. All about him. No one else can succeed. No one else can be in the spotlight. Only him. So my point is that I don't want to be that kind of content creator. I want to be the content creator who helps other people grow. And the point is, like, if you help other people, they'll help you. Like, there's no point, like, once in a while, occasionally, I do be asking people, like, hey, can you subscribe to the channel? Hit that like button, all this kind of stuff. But in reality, if you provide value, that will happen automatically. If you're providing value, then people will fucking value you and they will support you. They will support you. But I don't know. Some people are just selfish, you know? And they don't want to help anyone else. They want to be the center of attention. And that's just how they are, man. That's just how they are. One Piece has deep fucking value. Yeah, Dooley. No, Dooley. They pull the ladder up, they cut it up into pieces, they create firewood, and they burn it so they can keep themselves warm. No one else is coming up here. They ain't helping no one else. They made it. Everyone else can fuck off. And that's crazy, bro. That's crazy work. People like that don't deserve to be successful. Anyways, guys, I'm going to drop. I got to get something to eat, rest. My throat is fucking hurting, dude. I didn't realize reading, like just reading for an hour straight like that is exhausting. Holy shit. It's exhausting. But if you guys think that this stream provided value, go ahead and smash that like button. If you're not subscribed, hit that subscribe button so you don't miss future streams. And I'll catch you guys later. I'm going to stream later on today, though. We still got to react to that Fuzi VOD. We still got some other stuff we got to react to. So stay tuned for that. I'll be on later in the afternoon. I'm going to take a little break. Catch you guys later. Stay safe out there, man. I appreciate each and every one of you guys, man. Thank you. I'm out.